Hi, welcome to our discussion today, Women Leading the Future of Mobile AI. I'm Elizabeth Bramson-Boudreau, the CEO and publisher of MIT Technology Review. Our conversation today will be led by two women who have been at the helm of AI research and applications. It is my great pleasure to introduce Susie Armstrong, Senior Vice President of Engineering at Qualcomm. Susie has had a varied career at Qualcomm, including responsibility for the development and commercialization of the software that drives Qualcomm's chipsets. She's also been involved in policymaking in the government affairs group at Qualcomm, advocating for STEM education. Susie will speak with Daniela Roos, professor of electrical engineering and computer science, and the director of the Computer Science and AI Lab, known as CSAIL, and the Deputy Dean of Research for the Schwarzman College of Computing, all at MIT. The focus of Daniela's work is toward a long-term objective of enabling a future with machines that are integrated into the fabric of life, supporting people with cognitive and physical tasks, with applications from monitoring the environment in underwater exploration to smart cities, medicine, and in the home, daily tasks like cooking. Both women are invested in making AI available in everyday life, from mobile device enablement to whether it's pioneering the field of AI from wireless devices to robotics. And they're both pioneers in the role of women in tech, and specifically women in AI. So this is a big topic. We're going to focus on women in AI in this discussion. And I'd like to start by asking Susie about the role of women in the continued development and adoption of AI technologies. What makes women critical to the successful adoption of AI?
Thank you, Elizabeth, and thank you, Daniela. It's very good to connect again, and it's an honor to be a part of this fireside chat. In terms of women in AI, it's imperative in AI, just like other STEM fields, and probably even more so, to get women into the conversation, not just the conversation, but in the design, the inventions, and the technology that goes into AI. If you don't, you are leaving so much talent on the table, and you're leaving a very unique perspective that comes from women. So I think it's imperative to have women in these conversations. And, you know, one of the examples I have of women in technology is some of the Qualcomm women have created an AI technology that helps fine-tune the RF channel, which I think is a really interesting application of artificial intelligence in mobile phones and mobile chipsets and mobile devices. Again, imperative to get women into this conversation so you don't leave that talent on the table.
Susie, I completely agree with you. And in fact, women have such interesting, fresh ideas to bring to the table. There are so many examples of women advancing AI, advancing computing, whether they're thinking about algorithms or tailoring hardware to machine learning systems and algorithms, or building intelligent machines, thinking about what it means to be intelligent, or inventing the future of different industries, even the future of fashion, for example. All these women have fresh perspectives on tackling big global challenges while advancing the science and engineering. And it is this diversity of experiences that women can bring to the table that help us advance. And I would just say that, in fact, we need everyone around the table. And it is up to us, the industry leaders, the business leaders, the research leaders, to make sure that everyone is around the table. Because when we have all these different voices around the table, we'll be able to focus on what is achievable rather than who is around. And so there are so many extraordinary examples. You gave an example from Qualcomm, Susie. I would like to point to an example from CSAIL, where Regina Barzilay has been a real pioneer of advancing the use of machine learning for women's health. In fact, her system for doing early detection of breast cancer has very high accuracy and is already deployed in some of the leading hospitals in the world. If you value innovation and creativity, diversity is critical because not only does diversity bring fresh new ideas to the table, but diversity also forces people who sit around the table to think outside of the box, to anticipate different perspectives, and to come together to have a more comprehensive view of what is happening or what should be decided. But of course, diversity is not enough. There are so many examples of dynamics that push women out of technological fields at a rate higher than men. So we have to be aware of those dynamics and make sure that women participate, make sure that women can be role models for the young girls, can be role models for researchers at every stage of their career.
And just to build on that, I think that unconscious bias is a huge cultural barrier. And it's not only the bias that some people might have against women in these fields, but it's also the bias that we women hold in ourselves sometimes. We have programs that at Qualcomm that look at getting underrepresented students involved in some rudimentary engineering at the 6th grade level. And what we have found is many girls, especially at that time in their lives, they don't see themselves in a tech field because they have no role models. They don't, everything in the culture tends to push them towards different kinds of careers. And I think that kind of cultural bias, as well as bias that you inevitably run into at work, is very damaging and is something that we must overcome to get women to go into these STEM fields and to go into things like AI, and to show women that and show these girls that these can be incredible careers. If you look at Daniela and you look at my career, it's going into a STEM field and then it being involved in robotics and mobility and mobile communications and AI has just been a phenomenal career. And so I think it's incumbent on we women leaders to make sure that we help others find their voice in these areas as well.
Susie, this is so important, and it's really important if you consider the work of the future. Because for the work of the future, the STEM fields, computation, technology, science, engineering, will play a central role. These fields are essential, along with other important skills like communication, creativity, critical thinking, among others. And so, what I would like is to have all kids, boys and girls alike, think about this. And when we ask them, what would you like to be when you grow up? I would like them to say astronaut, primatologist, AI researcher, roboticist, computer scientist, neuroscientist. There are so many possibilities. And we have to show the kids that these are exciting fields. But in order to get there, I think we also have to prepare them. I think we also have to give them the tools that will empower them so that they could be any of these fields. They could be leaders in any of these fields. And the way I see it, in the 21st century, technology should be part of literacy. And in fact, I would love for all the kids to learn about computational thinking and computational making. Because those of us who have the tools, who have the skills to make anything and to breathe life into what we make, have in some sense superpowers, because we can make real the things we imagine. And who wouldn't want to do this?
You're all speaking my language because in addition to being deeply passionate about technology, I am the mother of 2 tween daughters. and they are, sort of teetering on the edge of thinking they can't go into a STEM field because of probably a whole lot of factors that are external to their talents. So it kind of leads us into our next question, and I think you both have a unique perspective on this, and that's about the connections between academia and industry. So I'd like to start with you, Daniela. How are academic institutions and industry working together to promote more women in AI?
I think that it's super important for academia to work together with companies for so many reasons. From a technological point of view, we can support each other in extraordinary ways. Academic research is usually much longer term than industry research, and so university professors and students can show to companies what is coming around the corner, what are the exciting technologies, whereas companies can tell us what matters, so that we can answer the question, who cares? When we create new knowledge, when we advance the science, and working together to support the development of women students, women postdocs, women researchers is critical, because the rate at which we produce graduates really impacts what the workforce looks like for companies. So if we have a lot of students graduating, if we have a lot of women students graduating, then there will be a lot of opportunities for companies to hire a more diverse workforce. If we don't have them, then those opportunities will not be there. And honestly, we're not doing so well in the computing field as a whole. In fact, according to a 2018 McKinsey study, women account for only 26% of the computing workforce, and this number has actually fallen over the past 15 years, whereas women made big strides in other fields. For example, 1 in 3 lawyers is now a woman, as compared to 1 in 10 in 1974. And also in 2018, we had the first year of medical student graduates where the class was majority women. So how can we get there in computing? Because by doing so, we will be able to have equal representation. We will be able to have women's voices in a diverse set of issues, whether they are in companies or in academic research or in policy. And in order to make real change with machine learning and AI in general, we really need industry leaders together with academic leaders and policymakers, because this way we have the people who develop the technology, the people who know how the technology can be used, and the people who can create policies to ensure the technology can be deployed in a positive way.
Susie, you've spent a lot of time looking at this issue. I'd love to hear your point of view as well.
Yeah, I knew it's Daniela described it very well. It's a very practical problem and opportunity that companies have. If we are very involved with our Think a Bit lab and with First Robotics, with inspiring and engaging kids to go into STEM fields and engineering and AI and research and invention. But those students have to put in the many years of hard work at universities before they can actually go on to either research or go into a company. And so it's really critical for a company like Qualcomm, who is trying very hard to engage more women in its workforce, that the universities have the opportunity to actually engage women in becoming computer scientists. And one of the most disappointing things I've heard in the last 5 years is, anecdotally, in 1982, when I graduated with a bachelor's degree from Cal Poly, there was probably 25% of my class of my computer science classes were women. And now Daniela's statistic is roughly, it's about the same. So what has happened in those years since then? We really need to, especially in computer science and computational thinking, we really need to make better progress there. And that's something that Qualcomm, who hires lots and lots of software engineers and as well as hardware engineers and AI people, really is really focused on with our work, again, with universities, with engaging kids in Think a Bit Lab and First Robotics. But it's a messy problem because it's not a short-term problem. It's an investment of 12 years of schooling to turn out people and women who can participate to this level.
But see, Susie, I believe that if we start in kindergarten and we begin to teach computational thinking and making, and we bring in new ideas and new kinds of kits, new approaches to teaching these skills, then by the time the students graduate high school, they have the skills, and then they are empowered to do anything they want. They are really empowered to use computation in substantive ways. So, Elizabeth, you were talking about your two daughters. I also have two daughters, and I watched them grow. I watched them go through their school education, and I got really inspired by that to create a new platform for education, one that both teaches computer science and supports making and thinking. And so what we did was we created a robot garden with flowers that are little robots and that light up. And these flowers can be also used as the nodes of a graph. So you can implement classical computer science algorithms like deep search or breadth first search, and you could see it light up the garden in different ways. That makes understanding the function of the algorithm better, and also brings a certain design aspect to the work. So by making the work more physical, I think that we can bring in elements of design. We can also bring in ideas that enable us to connect computation to various challenges and applications in the physical world. And I would tell you that a lot of our students really care about that. A lot of our students want to master the skills, want to master the tool set in computing, but they also want to have impact. They want to make a difference. They don't want to just hack in a corner. They want for their work to matter, whether it's in urban planning or in journalism or even in art. And so I see a lot of opportunity at the intersection between disciplines because now we have a lot of tools. We have wonderful smartphones. We have great communication platform, edge computing. We have so many of the basic building blocks that can truly spawn a revolution in how we use and apply intelligent algorithms.
And if I could just add, you said something I love. First of all, I want a version of your robotic garden, please.
Same.
Sounds so fun. Second, I love.
It's actually paper, so it's printable. You can just print it on your laser cutter. You can cut it together, and then you stick in some lights.
Excellent. I'm there.
Like in 2 hours.
Okay, I will be emailing you after.
And the other thing is, I love your term computational making. I think one of the things that has brought in women and people of diverse backgrounds to these STEM fields and artificial intelligence is the whole idea, the whole innate desire of every kid I've ever known to make something, to create something. I mean, years ago, we used to call it craft. And I think, and that's one thing I love about the maker movement, is it really captures this idea of taking this innate ability and desire to actually make something and, focusing it on whether it's art or whether it's it's technology. So I love computational making. I'm going to use that again. And I think that, you mentioned starting in kindergarten, and I think that's actually really important, because it's at that age when kids are really experimenting with being able to make stuff and being able to create stuff. And then, over time, especially for a lot of girls, that ends up going by the wayside. But I think that's an important part. And I heard a statistic years ago that any progress that we were seeing to have girls go into computer science and things like artificial intelligence was thought to be partially the fact that robotics had gotten cheap enough and had gotten forward enough and accessible enough that you could have a tangible outcome of your program, instead of, like I did, hello world.
Right. Well, exactly, and perhaps I'm biased, but I tell you that when you make something and you see it come to life, it's so extraordinary, and then to be able to design anything, to be able to use the building blocks, and then turn your imagination into reality is so energizing and empowering. And I'm excited about this possibility for the future, and about everything that we have to contribute from MIT side, from Qualcomm side, from other universities and businesses to help inspire kids at an early age.
For me, it's a thrill of showing somebody the latest phone, and showing your mother the latest phone, and realizing that how many tens of thousands of people that came together so you can text a message, and being able to tell your mother, look, there's a little piece of me in that. That kind of thrill is just unparalleled.
I just want to underscore that and say that even at this point during this pandemic, it's really technology that is making it possible for us to stay connected. Just because we can have this interview, we can have this conversation over the internet using a variety of technologies that our fields have developed. This actually shows us so many possibilities for technology to be thought of, or to be used as a vector for good, as a way of empowering people to solve individual problems and some of the world's greatest problems. And this is where I see the role of machine learning and AI, fueled by great ideas from companies, from universities, from kids, from adults, from everyone,
including women.
So let me ask you, we could talk about this, I feel sure. But can I ask you, maybe I'll start with you, Susie, for a parting thought that you would like to share with any women or girls who might be watching this discussion?
I think it's related to what I just talked about. When I can show, in my case, the latest phone that's running the latest software and chipsets, that I can show my mother and I say, look, Mom, do you know how many people came together to make this? And do you know there's a little part of me in that phone? And that tangible piece is, and to be able to know that you were a part of this is a feeling of success that is just exhilarating, to know that you actually contributed to this, and you actually made, a little piece of you went into making the world a little smarter and a little better.
Susie, I'm so inspired by what you just said, and I would just add one idea. I'd like to paraphrase our hometown hero, President Kennedy. I'd like to challenge the girls to think not just what technology can do for them, but also what they can do for technology.
Yeah.
That's
wonderful.
Great. Wonderful. Great discussion. I want to thank you, Susie Armstrong, for your time, and Daniela Roos. Wonderful to bring you two together and to have this conversation. And thank you all for your time.
Thank you, Elizabeth. Thank you, Daniela.